Hello everybody. I hope you guys can hear this, and I have adjust my microphone volume a bit here, so hopefully this is good. And for the desktop audio, maybe I can try adjust it slightly too. So hopefully it's not going to be too, how do I say? Hopefully it's not too small, so it's good. So let's go, I guess. So, hello everybody, and good good evening or good night if I have to be a little bit formal here. So yeah, it's actually night here in Sarawak in Borneo at 10 almost 10:09 p.m. here uh, on 25 February 2026 in Sarawak in Borneo here. So hello everybody, and welcome to this stream. I'm your host today, Dennis Suguwa, for today's stream of the launch of the Starlink 17-26 from the Vandenberg Space Force base on the Space Launch Complex on the Space Launch Complex Dash 4E or Slick 4E. We're going to see the launch of it, onboarding the SpaceX Falcon 9 Block 5 rockets. It's basically SpaceX launches, so you already know the drill. So that's how it should have already looking, but so far so good. I don't think we have too much else to say here, so why not why not we go focus a little bit on the most important aspect stuff here. So let's go and watch uh, on here. Okay, I think it should be, yes, nice. I don't have any problem showing you here. Nice. Okay, so I'm actually pretty happy here. And by the way, I'm also going to use live feeds from the Space Affairs because, you know, since, see, how do I say, since the SpaceX they stream on Twitter/X, okay, it's pretty much sensitive to the latency, and it's highly guaranteed will decimate my cellular internet connection here. So rather than trying to figure out whatever behind the scene, might as well I'll show you a little bit about the mission for today. We're going to witness the launch of it. It's going to be 25 Starlink satellites that will be launched into circular, not really circular, more like low Earth orbit around, if I remember, 559 kilometers or 545, around that one. And each of the satellites, if I remember correctly, it's around 300 kilograms where we're going to watch it. And of course, this is the 11th flight for this B1039. Okay, correct me if I'm wrong there. Where it's going to launch on the of course I Still Love You autonomous drone ship, since the launches of these satellites usually will push the Falcon 9 configuration rocket to the maximum, so it does need that maximum amount of fuel propellants to, and also oxidizers to actually go to the correct orbit, proper orbit inclination and whatnot. So that's why. we are going to see here. So this is the countdown, and so far most of the countdown is already passed. But yeah, by now we also already passed at T minus 7 minutes into the launch. So the command flight, oh no, sorry, so the Falcon 9 begins engine chill, aka it's cool down. The rocket engines all on the first stage already in the process of cooling down uh, prior to launch, so it's not going to induce uh, mechanical and also, how do I say, and also temperature shock that could destroy the rocket engines. And afterward, at T minus 1 minute, the propellant tank pressurization to flight pressure will begin, and at the same time, the command flight computer will also begin the final pre-launch checks as well, aka it's going to automatic sequence launch. And also at T minus 45 seconds, the launch director will also give go slash no go, whether or not it's going for the flight or not. And afterward, at T minus 3 minutes, the engine controller will command the engine ignition sequence to start, and finally at T minus 0 seconds, Falcon 9 will finally lift off for the launch pad. Okay, and from the visual I've got so far, it's pretty foggy around the Vandenberg. I'll show you later. Okay, so this is the most important, how the sequence looks like. Okay, you can see this is okay. So this is it. As you can see. Okay. Okay, so this is the best I can try show you guys. So you can see on the diagram is the launch, and then later on in the ascent, and later on will be the stage interstage separation. On the first stage, we will see it's going to do some flip maneuver soon. Uh, with the cold gas thrusters that will flip the first stage, followed by the grid fin deploy, and then finally we'll see the entry burn start, which the first which the engines will light up to slow down the first stage to ensure that it's not going to be destroyed on the hypersonic entry there, and then followed by the aerodynamic guidance. But the grid fins will guide it properly back to the autonomous drone ship. In this case, of course, I still love you. And afterward, we will see the vertical landing, which the engines will light for one more time to prepare it for the soft landing into the of course I still love you autonomous drone ship. And then we are also going to see the second stage. Afterward, we will see not long after that would be the firing separation at 90 kilometers, and then followed by the payload separation, but this one will happen later on and we are not going to see it. This one around 50 plus minutes into the flight. Okay, and as you can see, this is the how the sequence actually goes. At around before 1 minute into the flight, the rockets will achieve supersonic Mach 1. Okay, should be around where the typical commercial aeroplane actually operates, or around before 10 kilometers. It will be reaching speed of sounds, followed by the T plus 1 minute and 12 seconds would be the max Q, which will be the peak mechanical stress induced on the rocket itself. And if it does not pass around that time, it's going to be pretty destructive for the rocket itself. And afterward, we'll see the MECO first main jet cutoff on the first stage at T plus 2 minutes and 27 seconds, followed by 3 seconds later at T plus 2 minutes and 30 seconds, first interstage separation, and then followed by the second engine start SAS1 at 7 seconds later at T plus 2 minutes and 37 seconds, and then we'll see followed soon after will be T plus 2 minutes and 58 seconds would be the payload framing jettison, and then we'll see at T plus 6 minutes will be first stage entry burns start, and then 20 seconds later it will end, and then the landing burn will begin at T plus 7 minutes and 52 seconds, followed by the T plus 8 minutes and 15 seconds will be the first stage landing. And then we will no longer see no longer after that we will see at T plus 8 minutes and 40 seconds for this mission would be the SICO 1 second engine cutoff number 1. And then later on we will not see in this flight would be the T plus 52 minutes and 57 seconds would be the second engine start SAS2, followed by the followed 1 seconds later will be the SICO 2 second engine cutoff number 2, and then will be Starlink will be deployed at T plus 1 minutes and at T plus 1 hours 1 hour and 1 minute and 49 seconds, one by one. So by now she have already go, so let's go in for the stream.
T minus 15 seconds.
All right.
T minus 10, 9, 8, 7,
7,
6,
6,
5,
5,
4,
4,
3,
3,
2,
2,
1.
1. Okay. Main engine ignition. And we should have liftoff. Okay, and liftoff from the Vandenberg. Oopsie. What's happening? Oh boy. Okay, but by now it should have already ignition. Okay,
Chamber pressures are nominal.
Okay, so as you can see, it's pretty foggy, so you're not missing much of the detail into the flight. All right, so here you go. All right, so into the flight, T plus 4 minutes and sorry, T plus
Power
45
telemetry nominal.
T plus 50 seconds into the flight, almost going into the supersonic
Equals
max Q.
supersonic.
Sorry, Mach 1. Okay, supersonic, and followed by the max Q.
Max Q.
All right, so we have already reaching max Q, maximum aerodynamic pressure, fully exerted on the rockets, aka also launch vehicle, which at this point it's already passed, so it's pretty safe and sound. And of course, before it reaches max Q or supersonic, usually the rocket engine on the first stage will actually be throttled down back to around 60% or even more, and then after that it will going up again to 100% once it's already reaching max Q. And yeah, in case you want to know what's happening with the sound, don't worry, it's coming from my Mastodon. Okay, from my Mastodon web page there. So you can ignore that a little bit. But however, so far the flight looks pretty good and looks pretty nice. Okay, I've already adjust here. Okay, and we are going to see the interstage separation, and by now the rocket engines has already been throttled down in preparation for that separation, and also to keep the G-force slot at very controllable level. Okay, and then we have main engine cut off.
Stage separation confirmed.
Okay, and we have stage separation confirmed. And here we go. Ignition of the Vacuum Merlin 1D on the second stage. As you can see, the reason why it's actually called as the Vacuum Merlin is that you can see the nozzle itself is pretty big, very big bell nozzle there, designed to be optimized for the space ignition.
Fairing separation confirmed.
Okay, and with pellet framing separation confirmed way earlier than 90 kilometers around ballpark. Oh, it's already 90 kilometers, but it should be good. Okay, so the reason why it's actually vacuum Merlin engine on the second stage, why it looks pretty big there, is that because it needs to be optimized for the vacuum operation there. And by optimizing the vacuum operation, um, with with l- with enlarging by enlarging the uh, rocket nozzle, you can actually recover most of the uh, most of the thrust lost as a result of the flood as the result of the infinite vacuum expansion, as there is almost no atmospheric pressure that keeps the flame, keeping the flames on the shape of the lining rocket nozzle itself. So that's why it has to be made pretty big there. But you cannot make it way too big, because otherwise, if you make it too big, it's going to negate every possible benefits of doing it, because of course, as mass is making it way bigger also means you're adding more mass, you're adding more weight into the rocket nozzle itself, to the point there's literally no point at all to actually use it into the vacuum. And yeah, most of these uh, on the first stage booster and also on the second stage, it's already passing the carbon line, so it's pretty good news there. Okay, and carbon line is actually defined around 100 kilometers boundary of altitude, as already calculated before by the von Karman, if I remember correctly, that it's basically internationally agreed. That's where the space boundary begins. And on the first stage, already going back down from the command line, but at least on the US defined space boundary, it's not yet. It's around 80 kilometers for the US space boundary there. Or let's just say like this. Command line actually starts around 100 kilometers, aka 80 miles. And while for the US defined defined space boundary, it begins at 80 kilometers, aka 60 miles, and it's already going down back from the US space defined there. So we shall see
Even when
the
FTS is saved.
Okay, so we shall see the entry burn will start, and FTS step safe there on the first stage. As you can see, first followed by the another two sets of the Merlin 1D on the first stage. Engine has already started the burns. Okay, that one is to properly slow down the first stage
Stage 1 engine
booster
burn shutdown.
in preparation to ensure it's not going to be fully stressed with the hypersonic hypersonic heat entry there. And of course, another reason is that to ensure that it can properly slow down back to guide it back to the landing autonomous landing zone there. So that's what it's very important. Okay, so let's see. Okay. Ooh. Okay. Okay, it's pretty laggy, but this is my best effort so far, so don't worry. Okay, by now it should have already start the landing burn. Okay, I don't know what's happening. I hope this is okay. But by now should have already start. Okay, I assume already start the landing burn. Okay, and also by another of my calculation here, we shall almost going into the uh in into the into the Seco one. Okay, and for whatever. Oh, okay, never mind. The outages should not be like that. But yeah, okay. And here we go. On the second stage,
Shutdown.
it looks pretty good, and we have already reaching the shutdown there. And because due to the technical problem, so I need to go again with the replay. Pretty much apology. We, I didn't expect that to even happen around this one. Okay, so let's go back around here. So let's go back at the time where it actually launches. So let's go on the launch replay. Just pretend we didn't have any problem here. Okay, so let's go back again to the startup and to the liftoff until
T minus
the
10,
second engine cut off.
9, 8, 7, 6,
Okay,
5, 4, 3, 2,
and then you can see
1.
on the first stage engine
Ignition
already start and ignited.
and liftoff. Go SpaceX, go Starlink.
Yeah, so this, you can see there it's pretty foggy. That's why I said we didn't miss too much
Vehicles
on
pointing
the
downrange.
coverage there.
M1D chamber pressures are nominal.
All right, so you can see it's already lifted off almost 10 minutes ago. So this is the replay that I'm giving right now. Let's just pretend we don't have any problem on the early side there. Okay. And afterward, as you can see on Mach zero point 0.5, the rocket engines already throttled down back to
Power and telemetry
60%
nominal.
before it reaches Mach 1, the speed of sound. Okay.
Vehicle supersonic.
Okay. After that, Mach 1, supersonic there, and then followed by the max Q.
Max Q.
Okay, after that, it already reaches max Q, which is the peak mechanical stress in endured by the rocket itself as the certain velocities of the rocket itself, certain speed and certain atmospheric layer when these two actually actually meets together at certain boundary, it's going to be highly highly stressing the rocket itself that if it didn't pass the max Q, it's going to be really disastrous as a result. It could even destroy the satellite itself, but fortunately not today. So the Falcon 9 is looking pretty good in this replay. Uh, just almost just almost around 10 minutes ago. So and afterward, we also see the stage separation. But before this stage separation happens, of course, the first stage engines has already been throttled down back to 60% to not only to reduce the G-force load induced on the rocket, but also to prepare itself for the main gen cutoff, which on the first stage. This one is specifically a booster B 1039. And then after that, Miko mentioned cutoff. And
Stage
then
separation
interstage
confirmed.
separation. And afterward, followed by the second engine start, number one,
And back startup.
on the second stage engine there. Ignition of the vacuum Merlin engine there. That one is the optimized for the space operation. Okay, as you can see from the big rocket nozzle there, that one is to ensure that if anything happens,
Fairing separation confirmed.
okay, after that, followed by the pellet fairing separation around 90 kilometers. Okay, you can see there 90 kilometers. And of course, the reason why a vacuum Merlin won the engines is pretty important there is that to ensure that it can capture most of the lost thrust, lost pressure and whatnot causes by the expansion infinite expansion into the space as there is almost no atmospheric pressure there to actually hold the rocket exhaust flame there, keeping the shape inside the rocket nozzles there. So that's why it needs to be way bigger on the rocket nozzle belt there. But of course, there's one certain limit at some point where it cannot make way bigger than what it should have been. Otherwise, you are going to negate the advantages. For example, if you make it way too big at certain level, the thrust the thrust will not be able to overcome not able to overcome the mass, aka the weight of the nozzle itself, as more reinforcement needed to hold the rockets itself properly. So rather than making way too bigger, they will just find a way to cut where it's necessary using, of course, a, a smart rocket rocket equations math there, and some engineering ingenuity there. So that's why. And then afterward, we also see, so we also saw and witnessed the entry burn on the first stage booster there. It started by first started with the ignition of the core engine of nine, one of nine, followed by the another second set pair of another one left and right, which bring total 3 out of 9 million one the engine's ignition after that. And then when it shut down, it just follows the reverse sequence and then shut down. And we will see on the entry burn there as we are looking back at the replay. Of course, due to unexpected cellular internet problem, so I need to go back on replay. But hopefully we won't have this problem again on real stream, of course. When we have more ambitious stream, or hopefully we don't have that.
FTS is saved.
Okay, FTS if safe, which means that flight termination system
Stage 1 entry burn start.
flight termination system doesn't have to be used as aggressively as it has to use. So let's say, for example, if first stage for whatever reason does have some problem, they can activate FTS flight termination system to end
Stage
uh,
1 burn shutdown.
to literally destroy the first stage booster to ensure that it's not going to go outside of the trajectory, and also to minimize any potential casualties or even injuries on the ground. But in this case, it will be the sea. But since FTS is considered safe, and even the telemetry and also the tracking range considered pretty nominal, so there is nothing else need to do. They just only observing at this point, including the RSO, the range safety officer. They just only watch what it's doing, nothing to worry about. And of course, the first stage booster there literally guide itself back into the autonomous drone ship. But in this case, it will be the Of Course I Still Love You. And as you can see, it has a little bit of bounciness there on the first stage. Okay, that's pretty nominal. And also
Stage
that's
1
pretty
transonic.
normal as it goes into the certain boundary of the atmospheric layer there. And afterward, it's already gone back into the transonic, aka Mach 1, but no longer properly on the speed of sound anymore, as it already slows down. And then afterward, followed by the landing burn, start on the 1 of 9
Stage 2
Merlin
FTS is
1D engine there on the first stage, just enough to land it back properly into the drone ship
Stage
safely.
1 landing burn.
Okay, after that, we see the landing burn start. Okay, and then after the
Ignition terminal
landing
guidance.
burn, okay, as you can see, this is how it actually lands.
Stage
Okay,
1 landing leg deploy.
and after that, landing legs deploy and shut down, and it's already done its job, and the
Stage 1 landing confirmed.
booster actually survived its flight again for 11th flight. And of course, I Still Love You, autonomous drone ship still looking pretty good and nominal. So that's how the flight actually goes. Pretty smooth. And then we saw the second engine shut down, SAS1.
And back shutdown.
Okay, and after that, SAS1 already begins shutdown, and that's basically how's the flight actually goes by. It's pretty nominal, and it's pretty good. So yeah, not much else need to be discussed here, but that's it. That's the best we can see so far into the flight, and I hope you actually enjoy it, just as I do here. Yeah, even though we have internet connection problem for whatever reason, well, this is this is it. What else I can do? But hopefully on the morning side where we are going to see the launch of the HASTE rocket by Rocket Lab. HASTE is basically stands for Hypersonic Accelerated Suborbital Test uh, test what another engineering, if I remember correctly, aka basically it's a suborbital slash sounding rocket version of the Electron orbital rocket. Basically, it's an identical, not much else changes, but let's see. Because finally, for the first time ever, Rocket Lab finally decided to just officially go live. So we might see some changes in the procedure, or maybe plus minus. It should be, you know, there's going to be a lots of surprises um, in the book. So so don't forget, we are going to watch that in the early morning. I will start stream around 4:20 a.m. here. Okay, nothing to do with the week number. Okay, I actually intentionally chose that time, so I have a little bit of time trying to troubleshoot, just like you see on the early stream. That's how I do. I have time to troubleshoot, maybe even adjust anything if there's needed. Should it be needed? I thought I can do it properly, so that's why. So yeah, thank you so much everybody for watching. I'm going to see you soon again for the launch of the Husky rocket by Rocket Lab. Okay, where we are going to see the launch of the if I remember, Dart dash AE. Oh, sorry. Give me a little bit time. I have a little bit of burp there. Okay, Dart. I don't really know 100% what it stands for, but possibly something to do with defense accelerated or whatever is it, right? Maybe defense accelerated reentry test. And for the AE, actually already confirmed, stands for additive engineering. So my best speculation what DART actually stands for, and if we combine it, it would be something like defense aerospace or aero vehicle reentry test additive engineering. So this is my best speculation what DART actually stands for. But yeah, because as you know, there's literally a US military involvement in it. One of it, if I remember, is the Defense Innovation Unit. That one is at aka the private slash commercial company. They just subcontract that work that they contract or contract that work to the to non-government organization slash companies, and it actually does their job. In this case, if I remember, Hypersonics are actually responsible for the development of this hypersonic reentry vehicle, and also for the and of course you obviously can already know by now what application is it. Yeah, I don't have to explain too much, but we might see uh, some some of the telemetry might get redacted, or maybe just limited interaction. Who knows? Because U.S. military secrecy stuff. So I don't expect we might know too much about what is it, but it shall be very interesting, isn't it? So yeah. So I guess that's it, everybody. See you soon. It's the launch will be set around 5 a.m. here on 26 February 2026. That's our time here in Sarawak in Borneo. But back in the US, it shall be it still be 25 February 2026. So yeah, pretty interesting time. Yeah. So we shall see you soon. So this is my closing right now. I'm going to say it. So thank you so much everybody for watching. I'm Dennis Suguwa, your host today for the Falcon 9 Block 5 rocket launches carrying the SpaceX Starlink 17-26. Yeah, 17 26, okay, carrying 25 satellites into the low Earth orbit in the Walker constellation configuration, of course. Not the most optimized, but if you need to reach out a lot, well, one of it is it. But the best one would have been Flower constellation. Okay, so that's it, everybody. Thank you so much for watching. Take care. I will see you soon in a few hours from now. And also, as I need to take a little bit of nap as well for the live. Okay, so thank you, everybody, and take care. Bye bye, and see ya. And that's it. There's literally nothing else to talk about behind the scene. We've already talked whatever we want. So have a good day. See you soon in few hours from now. And also, if you're in my time zone or maybe whatever earlier time zone, please have a rest first. We will shall see you soon. And yeah, at the end of the day, behind this VTuber avatar, obviously it's human. I'm not an alien, so that's it. I do really need a good amount of sleep. And plus, by the way, being a full-time university student, really busy, so it's really crunching my time, and not every rocket launches I'm able to stream, unfortunately. Well, but so do we. But I hope we can still continue doing this in the future. So yeah, thank you everybody for watching, and take care. Bye bye. See ya soon.